thank you for being here. So, who doesn't like kebab? Well, I do. As a Mexican, it's like the closest thing I've been able to find in Switzerland to tacos. So I eat them pretty regularly. And at the local kebab shop, they gave me this thing. This is a loyalty card, or Treuekarte in German. So this thing, it's amazing because I can get 10 kebabs. I can use them 10 times, and then the 11th kebab is free. So this is basically what keeps me out of bankruptcy in Switzerland. so, so, and well, I happen to work for this GNU Taler thing, where some of us also like kebab. So one day we were like, what if we allowed shops to do this kind of things, but using the payment system itself? But not only that, but also discount coupons, subscriptions, and things that are not necessarily money, but that affect the price of things. So today, I will talk about how we did it. We did it using a very simple yet powerful concept called tokens that some of you may already be somewhat familiar with. And I will tell you about how we integrate them into Taler. So at the end of this talk, you will know what is Taler and how it works in general terms, and how tokens work in Taler, and how you can use them and what you can do with them. So let's get started. Oh, this is off. Okay, so but first, what is this GNU Taler thing? So Taler is a digital payment system that is analog to cash, but plus the convenience of modern technology, so you can easily and quickly pay from your smartphone, your web browser, or even your terminal. So also, I'm not trying to sell you any new cryptocurrency here. No, because Taler is not a store of value, but rather a means of payment. It's a payment system, so it can be used with any existing currency, the euro, the Swiss franc, and also Bitcoin, also any cryptocurrency that you want. So with Taler, you can pay very easily without registration because the money is literally stored in your wallet. So you don't have to do all those 2FA, two-factor authentication, and entering like 10 codes before you can buy. We all know how annoying is that. So Taler is very quick. And the best part is that Taler is 100% free software from top to bottom. So all the components are licensed under the GPL v3 license, and the server parts are under the Affero GPL license v3. So you can take the system and do whatever you want with it. You can run your own payment system if you want, or you can develop like e-commerce integrations of whatever you want. It's your call, hackers. So now I will explain to you in high level how does Taler work. So Taler is made up of many components that communicate over the network. So first we have the exchange at the center stage. That is the main component whose main job is to trade money in a bank account into digital cash in a wallet. And then we have the wallet, which allows you to store cash and do payments. And then we have the merchant, which is the software that allows shops to accept payments via Taler. And then they can use the exchange to do the other way around, so turn the digital cash into money in their bank account. So let's say the way this works, as I said before, it's analog to cash. So I will explain why. So let's say I want to buy some coffee. So using cash. So then I go to the ATM. I insert my banking card into the ATM. I enter my PIN, and I enter the amount that I want. And then the ATM will basically say, it will give me the money. So as you can tell, this €5 bill doesn't have my photo, doesn't have my name. It's just it's fungible with any other €5 bill. So the moment I go, so then I go to the coffee shop, and then I give them the €5, and then they give me the coffee, and I drink my coffee. So then, at the end of the day, the owners of the coffee shop all the earnings from the day, they will go to the ATM, and then they will insert the banking card, all the normal operation, and they will deposit the money, and then it will appear in their bank account. So the key point here, the purchase that I do is not linked to my identity. It is not linked to my bank account, because the moment I pay with this $5, the €5 bill, this is no longer linked to my bank account. It's just as I said, it's any other €5 bill. So the moment they deposit it, the ATM cannot tell who withdrew this originally. Who does it come from? So there's a privacy for me as the buyer. But now the merchant is a legally identified entity, so their income is transparent to the bank. So the bank can tell how much money they are putting into their bank account, and based on that they can do the taxing and all the legal stuff. And also important here is the concept of asymmetrical privacy. So this Taler provides asymmetrical privacy in the sense that me as a buyer, I am anonymous, as I said, and then the merchant can be identified and taxed. So it's asymmetrical privacy. So now, technically speaking, how does cash work in Taler? So in Taler, all the amounts, all the money that is represented by coins. So what is a coin? A coin is a key pair. It's a public key, private key that is generated by the wallet, plus a signature that is issued by the exchange. So here the exchange has a different signing key for every denomination. So for example, €1, €2, €5 is a different key. And also for the validity period. So this €5 bill that is valid from this day to this day. So it has a different key for all of those combinations. So whenever you stamp the signature into the key pair, you will get a coin that you can spend at the merchant. So now the exchange has a database of all the coins that it has received from the merchants. So it can tell if they are already spent. So that's how we solve the double spending problem. The exchange, the ATM, is the one keeping track of the usage of the coins. And it can also tell whether they are expired, because the signature is the one for the day before. So it will not accept it anymore. So there's no so the coins are, they as I said, they expire. They have a validity period from this day to this day. So what happens when they expire? Well, there's the refresh protocol. So that means the wallet will exchange the coins in your wallet for newer ones that are valid for a longer period of time. So it will renew them periodically, so you will never lose your money. So you can still, but if you were to lose it, then the money, the value, after the expiration, it will just go back to the exchange. But there's a privacy challenge here when it comes to all this signing. So how to unlink the spending of coins from the withdrawal process? As in, when we spend the coins at the merchant, the exchange should not be able to know who withdrew them originally. So, as I said, it has to be unlinkable to me, the purchase. So for that, we use a very neat cryptographical construct called blind signatures. So let's say you want someone else to sign a document without actually reading or identifying the document, but in a way that he or she can later verify the signature once its contents are revealed, and still not be able to link it to the original signing process. So this is how it works. This is an analogy of how it works. So you would have a message that you want to blindly sign. So then you put it into an envelope, and with some carbon paper, and then you close it. That's the blinding. So then you will send it to the signer, and then the signer, without opening the envelope, will do the signature, will sign it from the outside. And then what happens with carbon paper? It will transcribe into what's inside. So then I receive the sealed envelope from the signer, and then I open it, and then I can see that the document is already signed. But here's the thing: the signer doesn't know which document it signed. It cannot tell which one it is. It can tell whenever the signer sees the document again, he can tell that, okay, this is my signature, this is valid. I know that I signed it, and I can prove it. But I don't know when I signed it before, or for whom I did. And it's called blind signatures because it's like the signer is signing with the eyes closed. It's with eyes blinded. So it's as simple as that. This is the power of the privacy in Taler. So I will explain you how this translates to Taler. So whenever you want a coin, you want to have a coin that is valid at the exchange. So what do? The wallet will generate a coin. It will put it into this envelope with carbon paper, but as you can see, the coin is blank. So it will send it. It will put it in the envelope, carbon paper, seal it, and then I send it to the exchange, and then the exchange will stamp the five and the signature, and it will send it back to me. So now I can just open the envelope, and it's already stamped. But here the thing is that the exchange doesn't know which coin exactly was it the one signing. So whenever I spend it later at the merchant, I can just give the merchant this coin and then deposit it back. And then they know, okay, this is valid money. I signed it myself, but I don't know for whom I did sign it. And that's how we achieve privacy for the buyer in GNU Taler. So now, how do we actually spend those coins? So we do it through an order, which is an offer made by the merchant to the buyer, saying, for instance, you get this and this and this and this for this amount of money. You must be this years old in order to pay, and you have until this deadline to pay. You have until this date, and this is the amount. So in order to pay this order, the wallet has to send to the merchant a combination of coins of different denominations that matches the amount that you want to pay. So that's how it works. But what if we could use more than money to pay for an order? So now we introduce the concept of tokens. So what's a token? A token is a key pair generated by the wallet, plus a signature generated by the merchant, which makes a token. Does it sound familiar to you? Well, that's because in the behind the curtains, tokens are using the exact same primitive as coins, the blind signatures that I explained. So why are we using the same thing for tokens and for coins and for everything? Well, because so in order to ensure that all the parts of the system have the same guarantees when it comes to privacy, to security, because if we did like a mixture of different crypto, then we have the weakest link problem, and some of them have some vulnerability, and then the whole system is impacted because the system is as secure as the less secure component. So that's why we use the same thing, and it's actually quite nice. It works for everything. It's just you're just signing a key pair. That key pair can be anything. So now a token has no monetary value by itself, but it allows you to implement scenarios such as, for example, coupons, where, for example, I want to buy rice, and then I go to the shop, and then I pay 20 euros for 1 kilo of rice. A bit expensive, but okay. So you get 20% off coupon for the next purchase. So then the next day I come back with my, and I want another kilogram of rice. I ate it all. So now I have a 20% off coupon from the previous day. And then, okay, so then it will be only 16 euros. So this is for coupons. But then we can also, for example, loyalty cards, as I explained the kebab example. Like I go to the kebab, and then that will be 8 euros, and I get 1 loyalty point. So then the 11th day, because I ate too much kebab, I go to the kebab shop, and then I already have 10 loyalty points. And then the kebab is free, because I give those loyalty coins to the seller, and then my kebab is free. And there's also a bit more complicated, for example, the subscriptions, where our friend Alex, he wants to watch a movie. And okay, he has to pay. So he scans a QR code on the TV after he chooses the movie. And he has 2 choices. He can either stream for 5 euros, or he can get a monthly access for 25 euros. So he can watch as many movies as he wants, as he can, for 1 month, and then the next month he has to do the same. So yeah, that's how subscriptions work. But here's the thing, very important. every time, so you have the subscription token, the monthly pass. When you want to watch a movie, you need to give this token to the streaming platform, and then they will give you another identical token back that you can use for the next time that you want to watch a movie. That during over the course of a month. So why do we do this? Because this allows all my watching sessions to be unlinked from each other. So there's privacy, like a forward privacy, let's say, in this schema. So, okay, and there's many more possibilities. You have coupons, loyalty cards, event tickets, ballots for e-voting. You have subscription memberships, company shares. You can do a lot of things with this concept of tokens. So, but before we go any further, we need a way to put those tokens into some sort of category or family, so that we can assign different meanings to the tokens based on their function on orders. So, for example, we have a family for 20% off coupons, or we have a family for loyalty points, or we have a family for a monthly pass. So in Taler, we call this a token family. So basically, a token family is like a token printing machine. It's like a machine that it has like some template. It has the 20% off, and you can fill in the validity date, and you can fill in the signature. So you can print. You can have different like seals, let's say, for different kinds of tokens, and thus you can issue them based on the parameters that you configure. But in order for this token family thing to be any useful, you need to put this somehow into orders. You need to allow orders to express what do you need to pay an order, how many tokens you need, what kind of tokens do you need. So for that, we decided that we had to extend the order B0 that I explained to you. And we decided it was time for a new version. So that's when we came up with order B1. So an order B1 is like an order B0. It's very similar. But here's the key difference. Instead of having like an amount, like, okay, I pay this amount. Okay, easy as that, no. But here, we have choices. So here you can pay, you can give the client different choices on how to pay. And you can encode into these choices how many tokens do you need to pay the order. Aside from the amount, you pay the amount and how many tokens you need for this price to be valid. And also how many tokens are we giving you after you purchase. So all of this kind of combination, so as for example, the 20 you would have one choice to pay the full price, for example, and no need for any tokens, just the 20 euro for the rice, for example. And then you have another choice. So if you have one 20% off coupon, you will pay 16 euros. So you have different choices for different, based on what you have on your wallet. So going a bit deeper into the choices. So a choice is an amount, a description, so you can tell like this is the regular price, this is the 20% discounted price. And then you have inputs and you have outputs. And those are where you put the tokens. You declare what you need and what you're getting after you purchase. So here, for example, in this ticket, you would pay the full price, and then you get like a ticket that you can cut from the ticket and then use it the next day. Or you can have a choice where you are using your an existing 20% off that you have, and then you pay less. So those would be the two choices that you would be given by the merchant. So. And then every choice, every input, every output is a token, and there's a name for the token family, the slug. So you have 20 off or loyalty, whatever. You can set it up on the merchant, and the count for how many do you want to accept and how many are you giving back. So for example, in the kebab example, you would have 10. You need 10 loyalty points to get the free price. So this you would put the count. You would put it to 10. So you will need 10 to pay, and then or in the price you will have 1 because you receive 20% off after your purchase. Okay, so now we will dive a bit deeper for the developers out here who want to, I will explain how the JSON for the order would look like for different scenarios. So it's a bit more technical at this point. So here we have the coupon. So here, this is the rice example that I showed you on the drawings. So here we have 1 kilogram of rice. This is the description. This is what the user will see when they are paying. And then you have 2 choices here. So here you have the regular price, where you pay 20 euros, and you get back 120% of coupon here. This is the output. This is what you're getting after you pay. And then it is stored in your wallet. And then the next day, you're presented with the same order. And then you can use this order, which is 16 euros. You can use this choice, 16 euros. And the input will be 1 token for 20% off. And if you have it, then you can pay this choice, and you are paying the 20% less. So this has to be all declared explicitly in the order. This has to be all encoded there. And also the loyalty card. So for the kebab. So you pay 8 euros for the regular price kebab. And as an output, you will get the loyalty point. And then when you have 10 of them, you will pay this choice, which is the spending your 10 loyalty points, and then you will pay 0, and the input is 10 loyalty points. So that's how you would encode it. And now subscriptions are a bit more complicated, a bit more complicated, because here you have this. You have the order here, and you have 3 choices. So you have 1 choice, which is paying the single access. So here you want to pay only that movie. And you have another one, which is 25 euros, to buy the monthly pass. And as an output, you will get the monthly pass token. But here we have a very special choice, which is 0 euros, but I need my monthly subscription as an input. And as an output, I'm getting another identical subscription token. This is what I explained. So every time you want to watch a movie, you will pay with your monthly pass, and you will get another back that is unlinked from the previous one. It's blindly signed also. So now every time they cannot make a history of and link together all the watches that you've made and manipulate you psychologically, kind of thing, based on your watches or whatever. I don't know. So yeah, that's and at the end of the month there is like a expiration date. So this token family expires. This token expires in the next month. So the moment it expires, you can no longer pay this choice. You need to get another monthly pass. So now, okay, demo time. We will do a demonstration. So for that, what we will do is we have a demo blog, a demo shop, where you can pay using a currency called kudos, or test kudos in this case, that is worth nothing. So you don't have to spend anything. And we will buy chapters of a book from Richard Stallman called Free Software, Free Society. And we will be able to both pay every article, or we can buy a subscription to read as many articles as we want. So now here, if you want to follow, if not, it's okay. So first you need to download the wallet. You scan this QR code, and then you will be able to download it for your platform. But the iOS wallet does not support tokens yet, and the version from F-Droid it is not working. So you will have to download the nightly APK. Or Google Play is okay also. But iOS, no. It doesn't support tokens yet. Okay. Sorry, can we turn off the lights, please? Can anyone turn off the lights? Maybe it helps. Yeah, you can. I will. Is it any better? Okay, well, I will go to the... It's wallet.taler.net if you want to type it. Sorry, I will remove it a bit, sorry. I will open the browser. And yeah, contrast this a bit too low, I guess, for the... But
there is also light mode in the browser. I mean, it's heretical, I know, but...
Eh? And here's my phone, so you can see side by side what I'm doing. Okay, so here, wallet.taler.net. No, wait, I already have the wallet. I don't need to install it, but if you need to install it. So now we will go to bank.test.taler.net. That's the test bank where we will get the test money. So I will make an account. Datenspuren 2025, I guess. Password, definitely not password. That would be very insecure. So now I create this account and I will get 100 free test kudos. So now I will withdraw to the Taler wallet. I will withdraw like 50 or something. So continue. Please don't scan this QR code. You can. This is only one use, so I will use it myself. So let's go to the wallet, and then I will scan this QR code, hoping I can. Okay, no. So we'll just copy the. Let's try to copy the link. But I'm not mirroring the screen. So I need to. Okay, so I have the confirmation. I confirm. I accept the terms of service of the exchange, and so now I need to just confirm from the bank, and then I have the money in my wallet. So the next thing will be to go to the shop.test.taler.net, and here are the articles. I can choose any of them. So for example, this one. Yeah. So now I will have. I need to scan this QR code. Yes, again. I need to copy this. Oh no, it actually it made a sound. Okay. Anyway. Wait, what did I? No, I actually no, this is not copying. You need to let me just move this window to my computer, otherwise we will never finish. Someone scanned it? But you got whoever scanned it, you got the. Okay, I will do it again because I actually need this demo. Okay, I will scan it from my phone. And so can you see my phone? I can pay either the individual price or I can pay the monthly pass. So if I buy the individual one, I will have to do that every time. But if I want to the subscription, I pay 10 test kudos for the 1 month of access, and then I pay. So now here I didn't show the window. So here the article is immediately unlocked. So here you can see the article. So now next time I want to read another article, I will again pay. And then it's already, I didn't even need to do anything, as you saw. It immediately unlocks the article because I already have the token. It doesn't even ask me to anything. It's quick. It's immediately quick, incredibly quick. So now that's all when it comes to demo. So I will just finish. I will just close this. Annoying. Okay, so if any of you that was all for the demo. If any of you is interested in contributing to Taler, maybe you have some very nice ideas, some very nice integration, something that can change Taler and make it better for everyone, you can apply to our 9th funding call from NGI Taler. You scan that QR code, and then you can just do your proposal. We can help you with that, so you can reach out to us, and we can mentor you on this. Here are some further resources: the homepage, documentation, tutorials, source code, the bug tracker. It's all there. We are funded by the European Union and the Swiss Confederation. And here are some references. If any of you is interested in the math, in the crypto, in someone wants to develop some integration, the APIs are there. And if you want the slides, that's the QR code. Well, here's the link. I hope you can type fast. So yeah, that was all for today. Thank you very much.
Thank you, Ivan. You were very quick. We have 14 minutes left if you want to ask any questions. I can see hands being raised.
Thank you. Well, very interesting. I have one question about the exchange component you talked about. Is this exchange component like a server somewhere?
Yes.
And who is running that server?
So the exchange is typically it will be run by the bank who is offering the Taler service, but it can also be run by a central bank who is doing a nationwide currency tied to the euro, just the digital Swiss franc or whatever. It would be either the bank or the central bank.
So there can be multiple instances of multiple exchanges.
Sorry?
There can be multiple exchanges.
Yes, there can be multiple exchanges for a given currency, for any currency. But here the thing is that the merchant can accept all of them or many of them.
Okay, so the merchant has to choose which ones to trust.
Yes, exactly. Okay. There's the trust that way, yes.
Okay, thank you.
Okay, no problem.
Hello, nice talk. I wanted to say, I wanted to ask the renewal progress. So I have to go online every, a month, a week, every year, so it's not for long-term storage. So I couldn't actually store my signed signatures indefinitely, or at least for 10 years or something like this. I have to have a GNU Taler wallet that is online some of the time. Did I understand this correctly?
Not all of the time, because the moment you open your wallet, it will query do the operations that it has to do.
But I would have to look at it maybe once a year or once a month. So what are typical renewal times in there? So how often do I have to talk to the exchange?
So it depends on the expiration date of the coins, for example. So the coins will have an expiration date, and before they expire, your wallet has to renew them, to refresh them, to get new ones. So
yeah, that was the thing that I understood. How often does this happen? Is it is daily a normal thing? Is monthly a normal thing? Weekly? What are the time frames we are looking for there?
I can answer that. I'm from the Taler team as well. This is sort of not a technical question. It's up to the provider of the Taler system, of the exchange provider. So if they decide, let's say for legal reasons, they have to do it every week, then it would be every week. When they say they can do it every 5 years, then it would be every 5 years. So it's not clear to us, but the technology has the ability to configure this. It allows the bank to define what it is, but we cannot tell you right now. Does that make sense?
A little bit. Then the follow-up question would be: what happens if my Taler expires, if the coins expire, and is there a grace period for the renewal? Do they
okay.
This one?
Yes. So what happens is that the money will go back to the exchange. So the coin will be invalidated, and the exchange will get the money back, and you will not be able to spend it anymore. It's lost for you. Yeah.
We have a protocol that allows for that. If it's outdated.
Please talk into the mic if you want to talk, so it's on the recording.
If you, in those situations where you need your money back that is not valid anymore, we have a protocol in place in the exchange that allows exactly that. You can go and say, here is the money, it was valid, you see it was never used before, and even you see where it came from, like which bank account was the originating one. You have to prove it as a wallet. Here, this was the original withdrawal operation I got it from. And then the exchange can return it to the bank account that it was originally coming from. Okay? That's part of the protocol stack.
Okay. Thank you, Oscar.
Thanks for the presentation. I would have one question. What needs to happen for widespread adoption of the Taler?
So sorry, again, what is...
widespread adoption of the Taler, so for daily use.
so right now... So
what would need to happen?
So in order for widespread adoption, you need an exchange that is issuing the currency at the moment in the country or with the currency that you want. So that's one of like the challenges, because you need compliance, you need a lot of legal compliance and protocols to make sure that it's valid, it's legal to operate. And then you also need merchants who have installed the merchant software in their servers, or they can accept also via the wallet. You're doing like one-to-one payments, and then you need people who have wallets installed. So and also you need marketing, if you want everyone to know about it, and so you have enough places to pay with.
Okay, all right, thank you. I would have one other question. Are there any protections against a malicious exchange server, or do you just need to trust?
So that he can answer that better.
I'm glad you asked. Yes, first of all, in the whole design, there is a component called auditor. So when I say design, the protocol stack of Taler, consisting what the exchange talks, consisting what the merchant talks, there's an additional component called the auditor. That is an independent institution. It could be like a government institution overseeing banks. It has access to the exchange and can basically gets a copy of the data in the exchange, all the database entries, and can verify that they are doing their job correctly, verifying the signatures, but also verifying, for instance, a merchant could come and say, hey, I got 100 euros yesterday, but I don't see them in my bank account. What's going on? It can go to the auditor, and the auditor can check if the exchange actually did it properly, if, what's wrong there. So we have this. It is already part of the overall design that there is an overseeing entity. If somebody takes on this role and has the legal authority to do so, somebody needs to, have the authority to run this then. But that might answer your question a little bit. So yeah, it's not that you have to trust the exchange. Well, technically, yes, you have to trust the exchange, but we also have this concept of an auditor in place to control the exchange proper operation.
Yeah, maybe this is related to this. I'm thinking about the blind signatures. Yeah, so the exchange signs the envelope, not the coin, but the coin is spent. How can one see that this coin was signed really? Yeah, so when the exchange doesn't know what is signed, how can a third party trust the system that really the coin was in the envelope? Is it also realized using the auditor app, or is it different?
Okay, so the blind signature scheme allows for verification of a blindly signed document. So it using some cryptographic properties of inverses and stuff, you can make sure that a token was signed even if you cannot see so it's like as I said, the example of a carbon paper. It transcribes the signature on the bottom of the paper, so that signature is only valid for that document, and you cannot fork it, you cannot fake the signature. Okay.
If I understood correctly, an offer is made out to a specific exchange. So is there like a protocol to negotiate which exchange we want to use? Or do you expect that in practice there actually won't be that many exchanges at all, and there just will be like a European PayPal or whatever that has their own branding and everyone just uses this, and that European PayPal just happens to use GNU Taler, and like, yeah. Okay, so
it's basically a subset of the exchanges that you have in your wallet and the exchanges that the merchants accept. So it's basically, I accept these 10 exchanges, and I only have money from 2 of them. And if in one of those exchanges matches and I have enough money in those exchanges, then I can pay. Otherwise, it will not be possible. But there's not any very complex negotiation. It's just a subset of merchant and wallet.
This is a question about the tokens. Suppose I bought a subscription for a service. What would prevent me from sharing this token with my friends, for example?
So it's the thing is, you can only use it once. Every token that you have, you can only use it once, and then you have one back. So if you give it to your friend, they will spend it, and you will not be able to spend it anymore because he spent it. So then, I mean, it's technically possible to like share it, but it's not practical because it's only one use every token. You would need to share it like every time you want to use it, and only one of it would be able to use it at the same time, and it wouldn't be practical. We decided to not be practical.
I could just share it in a group chat.
Yeah.
That is possible. That is also possible with all the coins that you see. If somebody has an implementation of the wallet that shares the coins with them, it makes eventually somebody will find out and the service will not be provided anymore. I guess that's the thing. But you can turn the idea around and say this is even an opportunity where I can have, when some newspapers do that, you can get a token that you can actually give to somebody else. Like here, this is an interesting, I have a subscription, like a permanent monthly subscription, but not only do I get access to the article, I also get maybe 10 tokens that I can share with friends. So I can give them, hey, read this article, this is a good one. So in a sense, this is even maybe part of a solution where you deliberately want to use this token system to share. Yeah. But not in the sense to share the subscription, but access.
Yeah, but still, this requires trust between all of the friends, and it requires like constant reissuing of the tokens. It's not very practical. We didn't design it to be practical because there are use cases that make this a bit problematic. So it's kind of yes, he said it's possible, but yeah, it's not practical by design.
So we have 3 more minutes. I saw 3 hands up, so maybe we can get through all of these quickly.
Okay, quickly. Is there clearing between exchanges?
Sorry?
Is there clearing between exchanges, balancing of accounts? Is that built in? Just not or yes or no?
No.
Okay.
Not yet.
Not yet is what was said.
Can tokens be bound to a public key so the holder can prove he is the right person able to spend it? That would solve the problem with Abo. And maybe even subkeys, so the children and whatever spouses can prove they are part of the Abo memo.
I mean, we have a trust model for tokens, so you can actually so you cannot. So for example, you have your in your wallet you have the private key. So if someone doesn't have the private key, then he cannot spend the token. Yep.
As the spending schemes develop, will it be AP version 3, version 4, version 5?
You mean the token? The types of tokens depend on the version of the order. I mean, we made the order flexible, so you can put any kind of tokens encoded into the same contract. So it's no problem if you added more types of tokens, and it would be no problem if it would be. Yeah, it's all flexible by design.
All right. That was a good Q&A session. Please spend your clapping tokens now.
Thank you.